Okay, I just want to explain how to use this momentum graph. So let's say you have an object that has a certain mass and a certain velocity. You would graph this. This is initial, so this is before some kind of impact. So let's go ahead and graph. Like let's do a 4 by 8. No, let's do something. The math is easy. Let's do 4 by 10. Okay, so this rectangle represents the initial momentum, and 4 times 10 would be 40 units. We'll call them units, each unit being 1 square. Now, in reality, a unit would be what is meters per second times kilograms. So that'd be kilograms, meters per second would be the appropriate units. So now, let's say this object is traveling and it crashes into something. Okay, well, that would be applying a force in the opposite direction, let's say, and that would be let's see 3 by 4 makes 12. Okay, so this why is it negative? Well, it's because the impulse was in the opposite direction. Don't forget, velocity and momentum are vectors, right? And force is a vector. So this would be a crash in the opposite direction, slowing it down. Well, this is 40 units, and this is 12 units because it's a 3 by 12 rectangle. 40 plus negative 12 is 28. So the final momentum would have to be 28. Now the mass, right, the mass didn't change. So the mass is still 10. So I'd have to make it 10 by something to give me 28, and that would be 2.8. So it's kind of a weird number, but it would be 2.5 right about there. So if I was to write numbers, right, this would be 40 right here, 40, and then this would be negative 12 right here. Oh, I'm not the best at paint 3D, but I think you guys get the idea. 40 plus negative 12 equals 28. So just make sure your mass does not change for the object unless it loses mass, which is most likely not the case. And it has to mathematically make